Our next topic after preparation of dihydrogen is properties of dihydrogen. If we'll talk about its physical properties, then first is it is colorless, odorless, no smell is there in hydrogen, tasteless, lighter than air, insoluble in water, it does not dissolve in water, highly combustible gas. Now one question we have, hydrogen is relatively inert. Hydrogen is relatively inert at room temperature. It does not react at room temperature. Why? Because H, single bond H, this bond is very strong bond. So bond dissociation energy, bond dissociation enthalpy is the highest. Though it is a single bond, still the bond dissociation enthalpy is the highest for a single bond between two atoms of any element. The reason is because size of hydrogen atoms is very small. So when size is small, the bond will be very close. These two atoms will be very close to each other. A small bond will form which will be difficult to break. After this question, now we have chemical properties of hydrogen. Chemical properties of dihydrogen. Though its reactivity is less at room temperature, but still it reacts with some elements and compounds. Reaction with non-metals. Hydrogen combines with many non-metals, but at a high temperature in presence of a catalyst. Because its reactivity is less, that is why it reacts at high temperature in presence of a catalyst. Like example, hydrogen reacts with oxygen, but on heating or when electric discharge is passed through the mixture of hydrogen and oxygen, they combine to form water. So hydrogen reacts with the non-metal oxygen. It also reacts with halogens. Journal symbol for halogens is X. It reacts with the halogens fluorine, chlorine, bromine, iodine and forms hydrogen halide. Like HF, HCl, HBr, they are formed when hydrogen reacts with the halogens. Next example is hydrogen also reacts with nitrogen in presence of a catalyst iron. Promoter molybdenum is required here to increase the efficiency of catalyst iron. On heating at high pressure, the two they react with each other to form ammonia. So these are the three examples of reaction of hydrogen with the non-metals, oxygen, halogen and with the nitrogen. This is the first chemical property of hydrogen, that is reaction with non-metals. Moving on to the second chemical property of hydrogen, reaction with metals. Hydrogen also reacts with the metals and form metal hydrides. Like it reacts with sodium on heating and forms sodium hydride. It reacts with calcium on heating and forms calcium hydride CaH2. So hydrogen reacts with metals as well as with the non-metals. Third chemical property, reduction of metal oxides and ions. Reduction of metal oxides and ions. Hydrogen acts as reducing agent. It acts as reducing agent and it reduces the oxides of metals and their ions. For example, metal oxide, copper oxide, zinc oxide, lead oxide, iron oxide. With metal oxides, hydrogen reacts and do their reduction. It takes out the oxygen from these, that is, it does the reduction of metal oxides on heating. All these reactions take place on heating. So when oxygen comes out from here, taken out by hydrogen, then we get copper and water, zinc and water, in this case lead plus water, in this case iron and water. So in all these examples, hydrogen is doing the reduction of metal oxides. Now come to the reduction of metal ions. Dihydrogen also reduces some metal ions in aqueous solution. So when we take any lead salt in solution form and add hydrogen gas, it changes it to metal form. Copper ion, when reacted with hydrogen, then also hydrogen will give electrons to this and change this to copper, and hence hydrogen is reducing the metal ions also. So this is the third property of the hydrogen, that it does the reduction of metal oxides and its ions. Fourth, hydrogenation of unsaturated hydrocarbons. Hydrogenation of unsaturated hydrocarbons. If we take unsaturated hydrocarbon like ethene and react this with hydrogen in presence of a catalyst nickel or platinum or palladium, on heating, hydrogen will add up to the unsaturated carbon atoms and change these to saturated hydrocarbon. So from ethene what we get is ethane. This reaction helps in changing the vegetable oils to vegetable ghee. This helps in changing the vegetable oils to vegetable ghee. So these are the four chemical properties of hydrogen. After this we move on to the next topic of hydrogen, that is uses of hydrogen. Uses of hydrogen. Uses of dihydrogen. First use, in synthesis of ammonia. Just now we have done one reaction of hydrogen with nitrogen, and it forms ammonia in presence of a catalyst ion and a promoter molybdenum. This reaction is used for synthesis of ammonia. Second use, it is used in manufacture of nitric acid and nitrogenous fertilizers. The fertilizers which have nitrogen. In the synthesis of these fertilizers, dihydrogen is used. Third, in changing of vanaspati, ghee is manufactured. Vanaspati ghee is manufactured from hydrogen by doing hydrogenation of unsaturated hydrocarbons. In manufacture of organic chemicals like methanol. For example, carbon monoxide reacts with hydrogen in presence of a catalyst, cobalt, and it forms methanol. Methanol is formed by reaction of hydrogen with the carbon monoxide. Another use of hydrogen in manufacture of metal hydrides. When hydrogen reacts with the metals, the compound formed is called metal hydride. In preparation of HCl, hydrogen is used. In metallurgical processes means extraction of metal from its ore. In these processes, the heavy metal oxides are reduced by hydrogen to metal. So to get metal from its oxides, hydrogen is used. Like in this reaction, when hydrogen reacts with metal oxides, we get the metal. So in metallurgical processes, to convert metal oxides to metal, hydrogen is used. Next use of hydrogen, atomic hydrogen, that is H, not H2, atomic hydrogen and Oxy Hydrogen Torch. This is used for cutting. And for welding purposes, because there is a lot of heat in this. That is why it is used for cutting and welding purposes. It is used as rocket fuel. It is also used in fuel cells for generation of electrical energy. So these are some of the uses of hydrogen, where hydrogen is used. In synthesis of ammonia, nitric acid, vanaspati ghee is made. Some organic chemicals like methanol is made from hydrogen. Metal hydrides are made from hydrogen. Hydrochloric acid is made from this. In metallurgical processes, hydrogen is used. In Oxy Hydrogen Torch, it is used for cutting and welding. As rocket fuel, it is used, and in fuel cells for generation of electrical energy, dihydrogen is used. Now, after doing this topic of hydrogen, its position in periodic table, its preparation, properties and uses, now we have our next topic, compounds of hydrogen we have to study. So first compound of hydrogen that we'll study is called hydride. Dihydrogen combines with H2, combines with almost all elements except noble gases and forms the compounds called hydrides. So with any element, when hydrogen is combining, the compound formed is known as hydride. These hydrides are classified into three categories. They are classified into three categories. The first one is Ionic Hydride. Ionic Hydrides. These are formed by group 1 and group 2 elements, that is with alkali metals and with alkaline earth metals, which are highly electropositive in nature. Properties of these ionic hydrides, example I am taking is lithium hydride, calcium hydride, magnesium hydride. First property, these are formed by transfer of electrons from metal to hydrogen. Metal is transferring its electron to the hydrogen. Since the bond between the two is formed by transfer of electron, that bond is ionic bond. So these hydrides are called ionic hydrides. So these are formed by transfer of electrons from metals to the hydrogen atom. Second property, these are white crystalline solids. These are white in color. And which kind of solids are these? Crystalline. Crystalline means when the arrangement of the atoms here is regular, it is fixed, it shows long range of order. They have high melting points and boiling points. Since the bond is ionic, it's a strong bond. They conduct electricity. They conduct electricity, but in molten state. In molten state they conduct electricity. Like if I take the example of sodium hydride, in molten state we have to take it, and when we do its electrolysis, when we pass electricity through this, then it will break up to form sodium ion and hydride ion. At cathode, cathode is negatively charged, so positive ions are moving here. Na plus will come here at cathode, will gain electron and change to Na. While at anode, negative ion will come here because anode is positively charged, so it will pull negative ions to its side, and this will change to H by loss of electron. And when two hydride ions are here, this is forming H2 with loss of 2 electrons. So at cathode there is sodium and at anode there is hydrogen evolution. That is, they are conducting electricity in the molten form. This is the fourth property of hydrides. Next property, fifth one. The hydrides like NaH react with water. They react with water, but violently they are reacting with water to form metal hydroxides, with evolution of hydrogen gas. Hydrogen gas evolves out during this process. Next property of hydride, lithium hydride. It is unstable. So it is used in synthesis of other useful complex metal hydrides. Since it is unstable, so used in synthesis of other useful metal hydrides such as lithium aluminium hydride, that is LiAlH4. This is a very strong reducing agent. It is used in the organic chemistry to do the reduction of many compounds. This is a strong reducing agent. So this is actually helping in the reduction. So how from lithium hydride this useful hydride is prepared? lithium hydride is reacted with aluminium chloride, it forms lithium aluminium hydride plus lithium chloride is formed here. By this reaction, lithium hydride forms lithium aluminium hydride, a very useful metal hydride. So this is about the first type of the hydrides, ionic hydrides. Moving on to the second type of hydrides, metallic or interstitial or called non-stoichiometric hydrides. Metallic, interstitial or non-stoichiometric hydrides. These hydrides are formed by group 3, group 4, 5, 10, 11 and 10. By these group elements, these hydrides are formed, and plus the F block elements which are there at the bottom of the periodic table. By F block elements, these are formed. Some of the D block elements, and by the F block elements, when these are heated with hydrogen, we get metallic or interstitial or non-stoichiometric hydrides. The hydrogen atom here in these hydrides, the hydrogen atom occupies the holes in the metal lattice. Like this is the metal, any metal of these groups or F block, these are metal atoms. And this structure of metal is called lattice. This is called lattice. So the metal atoms are occupying these points. These points are called lattice points. Where metal atoms are present, those points are called lattice points. And these spaces in between these metal points, these are empty spaces known as interstitial spaces. These are known as interstitial spaces. So hydrogen atom occupies these holes, these interstitial spaces in the lattice of metal. Some of these they will remain, like for example here at these positions we have hydrogen. Some of these will be left unoccupied also. That is why these are known as non-stoichiometric hydrides. Now see these terms, metallic. Why these are called metallic hydrides? Because when hydrogen is getting into these holes of metal atom, gets into these, the properties of this compound are matching with that of the metal only. So these are called metallic hydrides. Why these are called interstitial? Because hydrogen goes into the interstitial spaces in this metal lattice. From this it has got this word interstitial hydride. And why called non-stoichiometric? Because some of these interstitial spaces are unoccupied. So the formula of this compound will not obey the law of constant composition. That is, example, LaH, hydrogen. This is not in the ratio 1:1. It is 1:, hydrogen is 2.87. Hydrogen here is 2.87. And further, this can vary also. Like titanium hydride, hydrogen is 1.5 to 1.8. With change in temperature and pressure, the formula of the compound can change. So its stoichiometry is not constant. It can change, it can vary. That is why this is called non-stoichiometric hydrides. So these three terms, metallic, interstitial and non-stoichiometric hydrides, I suppose are clear to you now. Okay. Earlier it was thought that in these hydrides, hydrogen atoms being small in size, hydrogen is small in size as compared to these metal atoms. So they come in some of these interstitial sites. That is why this is called the interstitial hydride. Properties of these metallic or interstitial hydrides, their properties. Since these are metallic hydrides, they are showing the properties of metals, like they are hard, they have a shine, luster like metals, they conduct electricity. They conduct electricity. Second property, they are non-stoichiometric. Just now I explained this part, non-stoichiometric. That is, these hydrides, they does not obey the law of constant composition. The formula here does not have these atoms of metal and hydrogen in whole number. We have hydrogen as fractional. And moreover, this can vary also with change in temperature and pressure. So these are non-stoichiometric in nature. Uses of these metallic hydrides, where these are used, the most important use of this hydride is in storage of hydrogen. In storage of hydrogen, these hydrides are used. Third type of hydrides are molecular or covalent hydrides. Molecular or covalent hydrides. These are formed by the combination of hydrogen with the most of group 13 to group 17 elements. Most of group 13 and 17 elements combined with hydrogen to form molecular or covalent hydrides. Example, CH4, methane, ammonia, water, hydrogen fluoride, etc. Now, these are further classified into three types. These are further classified into three types. The first one is electron deficient hydrides. Electron deficient hydrides. Example is group 13 elements. Group 13 elements like boron hydride, aluminium hydride. Boron and aluminium are group 13 elements. They do not have sufficient number of electrons to form covalent bonds. Like boron has 3 electrons in its last shell. When it is combining with hydrogen atoms, it will have 6 electrons, not 8 electrons, 6 electrons in its last shell. So it is electron deficient in nature. Since it is electron deficient, less than 8 electrons in its last shell, hence it is electron deficient hydride. Second type of hydrides are electron precise hydrides. Precise means exact number of electrons, that is 8 electrons in their last shell. These hydrides are formed by group 14 elements, like by carbon, silicon. They are forming these hydrides. Example is CH4, SiH4. Carbon has 4 electrons in its last shell. Carbon has 4 electrons in its last shell. Combining with 4 hydrogen atoms, sharing of electrons. In this way, carbon will have 8 electrons around it. exact number of electrons. So this hydride is known as electron precise hydride. So group 14 elements, they form electron precise hydride. So this is the second category of the hydride. Third type is electron rich hydride. Electron rich hydride. These are formed by group 15, 16 and 17 elements like ammonia, phosphine, water, example H2S, HF. These are electron rich hydrides. They have more electrons than required to form normal covalent bonds. That is, they have excess electrons which are actually present as lone pairs. One example is ammonia. This has 5 electrons in its last shell. Combines with hydrogen. It will have 8 electrons, but out of these 8 electrons, this is bond pair, this is bond pair, this is bond pair. These electrons are involved in the bonding. But these 2 electrons of last shell of nitrogen, which are not involved in the bonding, they are not required in the bonding. These are extra electrons called lone pair electrons, or also called non-bonded electrons. Though there are 8 electrons around nitrogen, but still it has these lone pair of electrons which it can further use in forming the bonds. So excess electrons are present here, hence these hydrides are electron rich hydrides. There is one lone pair present in case of NH3. So this is about the hydrides. When hydrogen is combining with other elements, the compound formed are known as hydrides.